Okay, guys. So firstly, we have to know one important thing. What is that? In terms of photoelectric equation. So basically, the incoming photon, if we just consider the photon like this by the green pigment, so the photon may carry certain energy that in terms of what? HF is the energy and H is the Planck's constant. Meanwhile, F is what? Huh? F is the frequency.
Frequency, right?
Yeah, that's the frequency. Good. So when it strikes a certain metal surface like this, shining on the metal surface, an electron which is just on top of the stuff like an outer electron. So the shining radiation may provide its own energy to this one. All the energy is being absorbed by this electron. Now it's just no, assuming that there is no waste, right? No loss of energy, its whole energy is being absorbed. Now you have to know one thing. Firstly, you have to get it rid of. So imagine the electron was tied to the metal surface. It's not that physical tying, it's like a electrostatic tying, right? But imagine like it's been tied by a certain strand like this. Firstly, you have to cut this strand, isn't that?
Yeah.
Remember that there is no such strand. I'm just explaining. So firstly to cut and get it rid of. So that energy is known as what? The work function. Work function is what? H F naught. F naught is what? What is this F naught?
Can't remember, sir.
Threshold frequency. Threshold frequency. Threshold frequency means the minimum requirement of the frequency to get certain electron rid of. I explained you this in the last week.
Yeah.
Okay, so once you have just spent your amount in that getting rid of the electron, like of the removal of the electron is like the work function. So there is a certain rest of the amount, additional amount. So the additional amount is what? The extra is what? Incoming photons energy minus this work function. So whole extra energy is being used to what? Whole extra amount is spent on what? Spent on?
Kinetic energy.
Yeah, kinetic energy. That's called as what? Kinetic energy. So that's called maximum kinetic energy. So it's called K max. So finally we can get like K max equals to E minus Y. So we can rearrange this equation like in this manner. The total energy is going to spend on work function as well as K max. Since we know what is work function here, work function is this pi value, can substitute over there. And energy, I just wrote the energy factor. What is my energy factor?
So the work function constant value for different metals or different values for different
values for different metals.
Okay.
It depending on with the metal to metal, because like a soft metals like sodium and potassium, it's really easy to get it rid of because these are the ones that are really high.
Aluminium must be high, right?
Aluminium is higher than what? Sodium and potassium, but lower than those metals like gold and silver and iron.
Okay.
Because they have a really strong structure. So because the cation is a really big one, that means the positive charge is really high. It doesn't like to get these electrons rid of. Right?
Yeah.
So now K max, what is this K max? equals to half me v max square. Now I can substitute this one to here. So my finalized equation is going to be like hf equals to hf naught plus half me v max square. So this is what my finalized equation. So copy this down to your book. Okay. Now everything is appearing on the screen. Just take your note.
So ME mass of electron, right?
Yeah, mass of electron. That's why I put it like me. Did you copy that, Chamika?
Yes, I'm finished.
Chamika,
Yeah.
can you see this one? So according to the textbook, it says something like the photoelectric equation. Let me explain you that using the textbook even. So the same thing, but the textbook represents it with some like of a weird manner. Okay. The Einstein's developed equation and equation photoelectric thingy. So it says what? So you may read it later. So the K maximum possible kinetic energy is half mv max. For an electron, I also included me that for you to remember. Vmax of what? Vmax is the maximum velocity. So Vmax is equal to hf minus pi. That's what I explained, like extra energy, delta E with what? Equals to E minus pi. So they have added the values. So that means half MV max equals to HF minus pi. So HF equals to pi plus half MV square. But I also went to some further step. Further step means HF naught is the stuff for this one. That's the finalized ultimate equation MV max square. So this is how I just obtained the equation. Can you understand it?
Yeah.
Okay, that's good. So let me send you some worksheets and
I got them. Sir. I got them.
okay. Now there is the summary note, right? Really simple summary note over there, right?
Yeah.
So this one may help you to get understanding the stuff.
So in this one, work function is W, right?
Yeah, the work function I just had like W note because I couldn't find out the Greek letter at the moment.
Okay.
By simple by. Then I installed that stuff even. Absorption and line spectra, everything is there. But I have to explain you the very next part. It's called the photoelectric cell. Let's discuss that in the next meeting. So before going for this one, we may have to discuss some of these questions, likes of the observations in this investigation. It's a really good something we have to do. So shall we start to do the question number 4 here in the
Okay,
worksheet?
sir.
Start question number 4. It has some other parts even. Start. I'll share you like maximum 10 minutes for this stuff. If you finish the stuff just before 10 minutes, just let me know.
Okay, sir.
Right, time is on now.